Up until now, we've included the weight of the beam as part of the weight of the load on when we're doing our equations. In practice, we need to calculate the weight of the beam separately. In the text I'm handing out with this lesson, it talks over how you need to calculate not only just the weight of the beam, but also things like the fireproofing on a beam, which is generally made of concrete. If you start going through the example provided, they also show you how to calculate the pounds per linear foot for that concrete. The equation is the height of the beam, D, times the width of the flange, B or BF, plus 3 divided by 144 times 144, which actually just cancels out the 144. So the equation, and the only thing you really need to enter for the equation is just D times BF plus 3. The text the text provided has a chart with what the weight of that concrete would be, but I'm going to show you how to add it to our table that we've been working with, that you made from last lesson with all the dynamic parts to it. So it's pretty easy. I'll provide the column here, so you just press equals D times parenthesis arrow over BF plus 3 parenthesis, and it populates the whole column. So that part's easy. If you continue working through the example, the first step of it is to calculate the maximum moment like we always had. You take the provided distributed load and the provided length, and you plop it into because it's a distributed load, we just take big W times length divided by 8. And with the little red tag cells, if you haven't noticed before, those are comments, and I provided what the equation is for that. That one seems to be being weird. There. So, like I said, maximum moment equals weight times length divided by 8. That gets you 76,000 foot-pounds, or as the book says, inch-pounds. And why won't this go away? Great. There we go. Maybe? Go away. Sure, whatever. Okay. Section modulus is your maximum moment divided by FB, or allowable bending stress. So that would be 76,000 times 12 to convert it to inch-pounds, divided by FB, which will give you 38. Then, just like we have in the other ones, you would go over to your chart, table, whatever you want to call it, and you'd find something that works. I thought I had this frozen, but it's not frozen again. Freeze first column. And the book picks 1430. You'll find out why. We won't pick, once we get done with this, what I'm talking about in this video, we won't pick we'll pick the beams type last. So he picks 1430, which has a section modulus of 42. So we're going to need to know the difference between the selected beam section modulus and the calculated beam modulus. In the book it says 3.9. If you were to use the numbers we used in our chart, it's going to be 4, which is basically the same thing. So when you have that, you can move on to the next step, which is to calculate the maximum moment for the beam and the fireproofing. So the equation for that is, since both of those are going to be in pounds per linear foot, you'll need to use the equation little w times length squared divided by 8, which I show there. So that's going to be adding 30, this number here, plus 136, which is provided in the chart in the text, or if we look over at what we had just done on our table, it's 134.66, so about the same. So once again, that's add those together for get your little w times length squared divided by 8. That gets you 5,312 foot-pounds. And then section modulus is your maximum moment divided by FB. Convert your maximum moment to inch-pounds, multiply it by 12, divided by 24,000. That gets you 2.66. And the last step is to see if this number we calculated is greater than this number, which it is, so the beam should be safe. And like I said, we'll see that, let's see here, that would be, so these first two here, that would not be the case, because that'd be 38. These are both 38 something, so those minus 38 is not going to be greater than 2.66. So now I'm going to show you how to actually add more to our table here to make it more dynamic and actually quicker than doing it this way. So the first step is going to need this number, the weight of the pounds per linear foot of the beam type, because this is just text. We can't grab that 13 or 9 easily and use it in our equations, but it's pretty easy to calculate what this number is. So pounds per linear foot, the equation for that is area times density. And so the area we already have on our chart here, which is in inches squared, and density I found is 0.28 for the A36 steel that we have been using for all of our equations. But both of those are in inches. The 0.28 pounds per inches cubed, and then this is in inches squared. So to convert those, so let's first do our area. I'm going to press equal, parenthesis, area. Since this is inches squared, I want it to be feet squared. I'm not just multiplying by 12, I'm actually multiplying by 144, which is 12 squared, times 144, and then times density, so parenthesis again, that's, as I said, 0.28 pounds per cubic inch, so I need to multiply that by 12 cubed, and it's multiplied because it's pounds per inches cubed, not just inches cubed. If you can tell the difference, or wait, I did that backwards. I did this one wrong. This needs to be divided by 144. There we go. So this times 1728, which, like I just said, is 12 cubed. Parenthesis, enter. And as you can see, the number at the back here almost exactly matches up with the numbers that we just calculated. As you go farther and farther down the chart, especially the really large ones, it starts getting a little bit different, but basically the same. Okay, so now we have that number to use in our equation. The next step is to calculate the section modulus. We're going to calculate the section modulus and the maximum moment all at the same time for this column here. So I guess the first step is actually to calculate our maximum moment of the weight of the beam. So I'm going to press equals. So moment is going to be our little w times length squared divided by 8. So little w is our beam and our fireproofing added together. So parenthesis, parenthesis, this number plus this number in parenthesis times length, which we're going to grab from our calculator, which I've actually named the cell L. I said that's going to be squared divided by 8. So there's our maximum moment. Let's see, then all that times 12 to convert it to inch pounds. And that will be divided by our allowable bending stress, which I've named that one FB. And then press enter. Okay. So as you can see here at that 1430, we got 2.63, which is, once again, we're using slightly different numbers, so that's why it's popping up a little differently. Okay, the last step I want to add to this to make it really easy to read is to do conditional formatting like this. I want anything that's red, I want to turn anything that I can't use red here. So to do that, I'm going to go back to Home, Conditional Formatting, New Rule. I'm going to come down to Use a Formula to determine which cells to format. I'm going to press equals. I want, going back and forth, comparing each cell, I'm going to use a $sign L. So $L means it's going to use everything in this column. And I'm press 2. It's going to use everything in that column starting at the second cell because I don't need that first one. So that minus, once again, this first part's the difference between our selected column and the calculated section modulus. So I've already named this, it's S. So is this less than this column? So that's going to be, once again, $M, because that's the name of this column here, starting at 2. Now I gotta add some formatting to it. Let's make the text this light color there and fill it with this red color there. Press OK, and there it goes. Oh, I grabbed this one. I wasn't supposed to grab that one. 1 second. It's not a big deal, but we don't need it there. Conditional formatting, manage rules. Huh. I shouldn't have grabbed that one. Oh, because it's applying it to everything here, which that was fine. If you don't want that on there, we can go up to conditional formatting, clear rules from selected cells. There we go. And as you can see, something didn't go quite right. I ran into this before. Let's see here. Manage rules. Oh, yeah. That's odd. Okay, edit rule. It shifted it down to 3. 2. What is going on? Be careful with your arrow keys when doing this stuff. L2 and M2. There we go. Okay, apply. There it is. And as I said before, see now it blocked those two out because those aren't going to work. So the first one that doesn't have any red in it and is the lightest would be that 1430. So now you can use this calculator to solve all of our problems, which the problems are just going to be some of the past problems we went through that had distributed loads on them. So once you get to this point, everything else should be quick and easy.